Perfect.
Welcome everybody, and appreciate the invite, and good to be here. Mine is going to be a little bit different. I'm going to focus on systems almost entirely, a lot of machine learning within it, surrounding our R&D that goes back a couple of decades in our system, K-Yield. And so the title is Distributed AI Systems for Optimizing Human and Machine Intelligence. That's kind of our focus, always has been. So I will give a background here. 4 decades. Won't spend a lot of time here, but since I'm the founder of K-Yield and sort of the chief architect, it helps a little bit. In the 1980s, one mentioned as my late business partner, Russell Borland. He was an early employee of Microsoft. First PhD, I believe, about number 40 employees, something like that. We became friends. About a decade later, became partners in our lean incubator and lab. It was a knowledge systems lab in Arizona. And during that, through multiple networks we were running, built from scratch, that's where the yield management of knowledge, the theorem sort of took root and matured a little bit. And then later in the 2000s, I founded an early stage VC firm, kept on incubating what then was named K-Yield, and then moved over to Silicon Valley in a sort of a merger thing that just in time for the financial crisis, and had a year window. That didn't work out. So I walked away from that, came to New Mexico to mature K-Yield, which was our primary focus. Long-term relationships with the scientists here, SFI, and some in the national labs. And then when it finally became possible that where we could see the hardware applications and components that would make the K-Yield technically viable eventually, I filed a core patent application. And at that time, we were trying to negotiate with incumbent vendors because of it, good advice from some of my advisors at the time. I would have said the same thing, but as many of you know, probably that's very difficult to do in terms of just licensing into incumbents. So we continued on and filed the patent. The core patent was awarded, and moved on into the pilot stage, and worked on the next generation R&D. So we've been actually engaged for first technically viable about 3-4 years ago, demonstrated at very high scale and high security. That wasn't our system. It was actually identical data in somebody else's, a vendor, a common vendor. But at that point, we pivoted towards direct to customers. Okay, so here's the definitions, the parameters I'm going to use for this talk, and these are all mine that, in my publications over time. So there's really nothing new here, but I think it's beneficial to put some guidelines up here. Beneficial AI at the bottom is the only thing that I'm interested in, the only thing we work on. I would mention that in terms of the AI itself, in that terminology, we actually had some interesting discussions lately where I look at it a little differently. We focus on the narrow AI, not the general artificial intelligence. So the functions within our system are very narrow. Most of it is ML, machine learning, and so these are the parameters. Okay, now what I thought it would be best really to focus on the things that we've learned in terms of adoption and working, because we've worked with, at least personally, probably as many management teams as anybody, I imagine, over the last few years. And so these are the things that I found that govern the rules by which adoption happens or doesn't happen Obviously, we have the regulatory issues from governments. But for me, actually, physics is the most important, and that's been sort of the driving force, because if it's not physically possible, obviously, if governments enact, laws that we can't follow, they're not going to be followed. So physics has been our primary, guidance along the way of what is possible, and we stayed independent and self-funded and lean to be able to focus really on just what was possible. And looking back now is difficult, but I'm glad we did. Competition is driving most of the decision making in the management teams that I'm dealing with. It is, I'm not saying necessarily it should, but that's my observation in dealing with them. Clearly it is a competitive threat. Some see it as existential threat, probably accurately. But what is being overlooked, and this is a point I want to get across, is that there's a lot of opportunity as well. And you see that in moving over into different industries. So we're going to be talking a lot about, in my talk, about strategic issues in the business, because that's driving adoption, and it's also driving the type of adoption. And so the combination of the systems and strategic, intent and perceptions is driving everything. Well, economics, that's obviously an important part of this equation. Costs are falling in the hardware, but in a sense, it's a little bit like software, where it still requires a significant investment. So the benefits of the hardware is really good. It's enabled a lot of things, but the talent costs, especially at the competitive level, are still driving most of this whole sector of AI systems and machine learning. The open source, a lot of things are coming on that are free, but it's a double-edged sword, and we'll move on to that in a second in terms of differentiation and competitive issues. Corporate policy, I'll touch on that a little bit more. Not only does it influence the adoption, but it influences the governance of the systems themselves, and should. And that's an area that's very important to us that, I focus on a lot. So here's a few examples of AI systems. Familiar with most of these probably. There's a lot of different AI systems out there. The autonomous vehicles is one that's getting a lot of interest and investment. Here in the middle of the control center, that's a Rolls-Royce, which I recently watched in their video. If you haven't seen that, it's quite interesting. That's a global, single place that managing shipping logistics around the world. The F-35 on the right, Lockheed Martin, that's the fighter jet. That's probably the most advanced single system in the world right now, most expensive, one of them anyhow, one of the top ones. And what's interesting about this is that these are all have human interaction. So other than the goals for autonomous vehicles, we're not there yet. And so there's, even in the the Predator and the drone, those are humans somewhere far off in a remote location that are running those. So the human interface is still extremely important. I think personally will remain so. The Mercedes future in the trucks, been a lot of publicity on that in Europe, is quite interesting. That's going to have big significant impact on transportation and logistics, being able to automate that in more intelligent ways. And then finally, Google here, we're all familiar with that. Google, I'm quite familiar with them from the early stage when it was in the dorm. We tested actually their search engine algorithm in our lab. They have really come on strong. Many believe that they have the deepest bench and the most AI talent of any company in the world. I'm familiar with quite a few of them. Certainly is one of the strongest. They have an awful lot of artificial intelligence built into Google today, so that's a good one. But while we're here, there's a couple of others that are worth considering on the nano side. Smart pills is one that's of increasing interest. Nanobots, implants in healthcare. I think we're going to see a lot more of that in the near future from not just our own research, but in our discussions. and what's needed to execute precision medicine. These are some key issues in AI systems. Obviously, highly complex, very expensive to date. A lot of folks are trying to simplify that. We're one of them. In our case, when we're talking about enterprise-wide systems and governance, it usually requires leadership, the CEO, with the senior team consensus. We've actually gone through a number of employee changes of senior management, and some of the engagements that we've had. Part of that is probably because of capability in the team. I expect that probably will continue. One of the reasons why the CEO needs to be involved, COO, the board, governance issues, is because a lot of the decisions being made in AI systems today, these are among the most difficult decisions I think management has ever been faced with. Do we, completely transform our company into something else? We'll touch on that in a minute. Do we use, a commoditized platform to work on top of? Do we completely rebuild internally and spend billions of dollars like a few are doing? These are some very bold decisions, and if you're wrong, it could be catastrophic. So the strategic issues that are going on around this, and the consulting firms in the world have been among the most complex and difficult decisions that I've certainly confronted in my career in dealing with boards and senior team members. Growing number are really sort of betting the farm on AI. The more they look at it, the more they decide, look, we need to compete with Google. We need to compete with whoever. Because if we don't, they may decide, Apple may decide to become a car company. If we're a car company, we've got to have those capabilities. GE becoming a IoT company. So those are the issues driving it. Talent war is real. I don't really see that changing a whole lot. The number of individuals in the world, while there's an explosion in training and talent, it takes a long time to understand how to apply these things. Most of the senior teams around the world in the, let's say the top 5, 6 companies in the world with AI labs, they're still, they're run by people who've been around for a couple of decades. There's a lot to understand about this. System design and business models are critical. We're seeing that manifest now, and that's going to continue. One of the reasons we stayed independent, we didn't want business models or legacy issues, transformation issues, Wall Street, or any of that getting in the way of what was possible. So those are really dominating what's going on. And for customers and architects, it's important to understand that. Another thing that many are using this to expand in new sectors and new offerings. And that's an area that we're dealing a lot with recently. It's an area that I encourage folks to look more deeply into, because there's a lot of opportunity, especially in the global economy. We're not seeing much growth. There's actually a lot of opportunity to expand in new sectors. It just takes an extreme amount of focus and a lot of talent to do it, but the opportunities exist. Another thing that's important here in the system design is that in the modeling side, the old IT models are not necessarily best. When we're looking at the companies that are leading this area, they're typically not using the old IT model. So we need to rethink about intelligence. Is a different game than IT. Yes, we use IT to run it, but it is a different animal. It takes little different thinking. So I wouldn't presume to think that the models are necessarily. In fact, in many cases they aren't. Good example of that would be the automakers. They're becoming fleet owners. It enables to do that, autonomous vehicles. And if they don't, as I caught Brent's talk and Matt's earlier, chances are you're going to get replaced. Number 4, algorithms are dynamic and rapidly evolving. That's very important in terms of system development and design. It takes very high-end talent at the cutting edge to tweak them, to improve them within a system. Not very many companies in the world are going to be able to afford full teams that can do that, especially get into SMEs and smaller business and nonprofits. That's something to keep in mind. Machine learning, while it's being used in small projects now as an extension of analytics, that's not necessarily the right way to go. So this is another area where just as an extension of analytics is not the right way to think about this. So some examples are machine learning by its very nature is a continuous process in many applications. So if you do a one-off project and you use machine learning to learn something, you might get a little ROI off of that. Might be a good project, might be safe, but it's not going to resolve the strategic systemic issues facing your organization. And that is another really critical issue that I try and get across. And most, I can say that 3 years ago, management teams, senior management teams in the world's premier organizations didn't understand that very well. Today they certainly do. There's very few that we come in contact with now where it's not a high priority, or if not their highest priority. So commoditization is a double-edged sword. That's another thing you'll see a little bit later that we focus on from the get-go. How do we deal with this issue where commoditization is good in one respect because it lowers costs, but when you're transforming into this new company in the digital era, commoditization, you see the other side of that sword, is that it favors scale. Even Walmart, for example, is obviously having difficulty dealing with Amazon today. So the world's largest retailer is having scale used against it. So far Amazon is doing pretty well. So those are some key issues to keep in mind. Now on to our focus of our type of AI system in the workplace. And especially enterprise architects will be interested in this, I think. These are the disciplines, the main disciplines that have impacted our R&D over the years. The lot of hundreds, if not thousands, of hours dealing with leading scientists that go into this. So in some respects, it's actually more complex to design an enterprise-wide AI system because of us humans and our brains, which are actually the most complex things on the planet, than it is to actually build a robot. So there's more variables, there's more things to understand, requires more disciplines. You can't just be an engineer, you actually have to be a lot of things to do that. So that gives you an idea of our focus areas. These were the long-term R&D challenges that we faced, and we're not a basic lab or research lab. There's been a lot of it involved in this, but we're really looking to apply in a simple manner that makes sense, and the shortest way to do that. And simplify it, make it very easy. So these are the areas: commoditization, security, prevention, productivity, economics. The important thing from a system view, and we were early in using the term holistic. Now I use more of unified system because it's management teams seem to be able to understand that better. But in a network, these are all interrelated, whether we like it or not. You need a unified systems approach. We're discussing this actually in a LinkedIn conversation a couple of days ago, and the thing that I answer to, or I try to remember, is that if you think you can prevent major crises without a unified system in a global distributed organization with hundreds of thousands of employees, really it's kind of a myth. You're not going to be able to do it, and we get continual use cases that come out that prove that in the most sophisticated, advanced companies in the world. So governance is very important, and governance for organizations obviously critical. Regulatory issues, there's privacy issues, there's security issues, economic issues, and we have tried to wrap in the, we focus on the areas, I focus on the areas that are universal. So what are the universal issues in the simple form that we can put into this system and run the machine learning and the other algorithms that we need to do? And these top line things, in our case, we're inspired by nature, and have studied biomimicry a lot in detail, but these actual images are not to be taken too literal. They just represent, in my case, I'm actually looking not to replicate, let's say, the brain. I'm looking for applying computers and networking technology to get a beneficial output that is similar. So the outcomes are similar, not necessarily using the same tactics, which a basic research or a brain lab is doing today. And so that gives you an idea. Now, here we go into, we've just recently made this public, and we've been using with teams for quite a while, redacted some of the information. The core kind of patented part of ours is up in the AI augmentation part, not very strictly, but basically. And the KP are the areas that we have, trade secrets and things that I can't show. But if you focus on the AI augmentation on the upper left, this is, I wanted to show this is how you apply the yield management of knowledge theorem to an organization to achieve a continuously adaptive learning organization. That essentially is what we all should be trying to do in large organizations. Some are doing a pretty good job. Some have spent billions of dollars internally on it. I won't mention any names, but there are a few that are doing this pretty well, and guess what? They tend to be leaders. And so this is I think where we need to go. I wanted to share what I could on that. Now, it's important to understand here a couple of things. One is ours is integrated, it's open. We have always embraced standards. If you read any of my stuff, I've been very adamant about the need for open standards all along. And so a lot of this stuff, you don't need our system to do it. You can use others. In fact, there's several that have this built in, and they're improving all the time. Microsoft, IBM, Dell, they all have, there's quite a few out there. And so you can use, some have built their internal automation into it. But I wanted to show this is kind of the basic sort of minimal that you need to do. And then in our industry-specific designs, we have regulatory, they have reporting and banking now in the U.S. I think there's like 60 different reporting that we have to do. But this is entirely prescriptive. So in our AI augmentation, it's based on the profile and self-managed profiles and natural languages. You talk about precision medicine and getting down to the granular molecular level. This is what you need. You need that. We need to be able to do that. And the data is such high volume. When we get to that stage, we're not there yet because of a variety of reasons, mainly regulatory and protectionism and just being slow to adopt. But there's no physical possible way humans can deal with that amount of data. Same with the IoT and a lot of autonomous vehicles is a great example. I mean, it's just completely off the charts. We have to deal with machine intelligence to be able to do it, and so we have to do it. Now here's an individual module example. Again, we have just recently have been sharing this privately and a bunch of NDAs with companies previously, but I wanted to show what I could. Here's an example of a module in our system that is one way it manifests. Now there's a bunch of modules in our system And this is this is an integration. This is not, this is in no way represents all of our work. You'll see a Microsoft chart. There's a graph chart. There's a voice bot in the middle. We decided because of our limited small lab and resources, we didn't go down the voice pathway, just because in the early days, that was a DARPA project with tens of millions of dollars. That ended up being Siri. It took there's a lot of brawn, a lot of effort, a lot of money. Now, of course, there's a whole bunch of mature voice bots that are being used that you can choose from. Each one is a little bit different, a little strengths and weaknesses. So, and the same with databases. Years ago, 5 years ago, I think there was only one choice. Now we have, last time I counted, there was over 12 options that appeared good. So there's a lot of different options here. Okay, we'll just go down. Proprietary security that we have within our system, that is relationship-based and mathematically based. It's kind of an extra layer on top. We use deep learning within these modules to assist us in our own. Now keep in mind, this is my example for me. So if you're thinking in terms of a CEO of a larger organization, integrating some content, some video feeds. Above that, there's some alerts for preventative issues. At the very top, you can see the CKO admin up at the top. That is the engine that provides governance for the whole system and security and access and privacy and regulatory settings. And then a couple other things that is probably new to folks is the module data tuner. Over there on the right, it's just that little tiny thing under the Oracle of Omaha. That goes back to our early days. Wouldn't it be nice to have and that part of that is patented, by the way, so you need a license. We're flexible in how we do that with customers, very flexible, but it is patented, and that is to our profile. The data comes in, and I need to be able to manage my quality, not just my volume. And that was the really difficult part within our labs, within our networks. It's very easy to create information overload. It's very difficult to overcome that problem. It has taken 2 decades to make meaningful progress, and we're finally there. Knowledge currency is another one that we have in our system that is very important. We integrate with blockchain and offer that now, but the knowledge currency is not just financial. That's basically a sort of mathematical, customizable thing, and it can be, and it can be converted to other currency. But for example, in some organizations, psychological motivations are more important. You need to be able to do a wide scale, right? And it needs to be as wide as our different profiles and the different entities. So that's what the knowledge currency is all about. Okay, some use case scenarios. I wanted to share some. I know that it's one of the first questions that comes up with a lot of the companies that we engage with, I can't go into too much detail, obviously. The first thing I guess I want to say is it's a lot of work to do a really good use case scenario. You need to have a lot of information on the company, the industry, delve down into it very deeply. I'll give you a couple of really quick examples. One of my colleagues, Garrett Lindman, he's a geneticist, and we were working with big pharma companies engaged, and so we worked together last year on a really important one, and that is biomarker discovery for oncology. And so that's an example of something where you really need to sit down with experts and work on it for months. And so it's not a minor issue to come up with use case scenarios in these systems where you have a generic system that provides the universal issues, and then you need to drill down for advanced machine learning, decide which algorithms to use. I thought Matt's presentation this morning was quite good, quite interesting. That is essentially the world that I'm living in. And so But here's the biggest ones, industrial accidents. Going back, this has been one of my motivations on how to use these systems. We can prevent most human-caused crises now once we get these systems in place and they're managed the right way. In our case, certified. But that gives you an idea. Now, the nuclear disaster in Japan was not, that was a natural disaster. But the nuclear, actually there was experts that warned that the pumps were susceptible to flooding and a possible nuclear disaster. That's actually the norm. We have in our big political organizations, we have experts, and that's their job. 9/11 down here is another one, the Phoenix Memo, but we don't always listen to them. So how do we arrange our system so that we not only listen, but we take action, and we apply probabilities on those. In the more cases that we have, we can apply probabilities. So it's actually it's a much higher probability of prevention than most people are aware today. And so the Deepwater Horizon oil spill, the $62 billion, that's just for BP alone, in climbing. That was another one that is, from the information that we have, I think there's a high probability that if K-yield, it wasn't available then, but if our system were installed at the time, I have very high confidence that could have been prevented, or in some cases mitigated. VW emission scandal is another one. Not a lot of information. Apparently there's a criminal investigation going on, etc. But from what we can gather in public and in some cases in private, high probability that these can be prevented now. So in terms of ROI, in terms of funding, they don't get any higher. And on the disruptive side and on the being displaced, that's also true. So if you don't, the Detroit view is obviously if we don't embrace autonomous vehicles and become very, very good at this, there's a good chance we'll be replaced. So risk management platform, there's an awful lot of smaller events in our day-to-day, right down to the individual. Precision medicine is another one. But there's just there's actually hundreds of different individual use cases that I've come across over time that you can do on a smaller level. But if you take each one of those, it really adds up in an organization, whatever, or a public entity. Some more use case examples. In our case, we have industry-specific designs in the healthcare and financial, primarily due to regulatory issues. Accelerate R&D is a big one. We spend a lot of time with pharma companies on this issue. They have improved, but the patent cliff issue is still very important, and that drives a lot of investment. And the pharma companies have several billion to $10 billion or more in R&D. So the productivity of that is very important. And we've got some very good, I can't really share much on that, but we've got some very good intel on that. Accelerating R&D is one of the main reasons to adopt a system-wide, enterprise-wide unified system like K-yield. Avoiding disruption is another one, and being able to compete with the best innovators. This goes back to, again, I won't name any names, but companies that I'm very familiar with have systems sort of like this. They're custom built, very expensive. Very few organizations in the world could replicate it. They don't have the talent and they don't have the budget. But they are, in most respects, in most areas that they are working in, they're winning. Expansion into new markets, that's an area that we focus on more now. I encourage people to look at. There's just a mentality in business right now that there's no opportunity. This is a generational change in technology that offers lots of expansion opportunities into new markets, from the base that we're at in many cases, or in some cases new partnerships, new businesses, distribution, partnerships, all kinds of different things. So, you know, there are some examples. AWS is now the best business at Amazon, and they're picking up a lot of machine learning and AI capabilities. What's interesting about that is Amazon started as, you know, it's a very low margin business, but they learned an awful lot about e-commerce and networks and computing, and they applied that innovation in a new area that's actually a better business in terms of profit anyhow. And so that's quite interesting. It makes a great use case to study. IBM is betting the farm on Watson. You know, another use case where transformation is underway. GE becoming an IoT company. I mean, these are big companies that are radically changing in large part because of these new capabilities. And there is an element of AI systems and certainly machine learning in every single one of these now. Automakers, autonomous cars, fleet ownership, that's a pretty radical change in the history of cars. Insurance companies becoming operational guardian angels, that's another interesting one, where they're beginning to transform from purely financial into operational and executable systems. Okay, so here's some issues for chief architects that I thought I would share. On the educational side, this is an area I've spent a lot more time than I ever expected I would spend. We've made a lot of progress. The global consulting firms obviously have really grabbed hold of this and offering a lot of services. There's a lot of conflicts though, and alliance conflicts, and the legacies and the relationships that exist are now. I realize architects more than most understand this. At least my history of dealing with them is that they're in a very good position to understand this. However, with AI, I see it as really problematic. The advice that boards are getting are in many cases more biased and conflicted on AI system strategy than anything I can remember. The business models are also in direct conflict with customers, so that's another thing to really look out for in any of these AI systems. We've tried to keep ours as flexible as possible. We're, again, self-funded. We have the ability to do that, but boy, that's a really important thing to understand. There are companies that have tested some of the systems we've engaged with that are moving on because of those conflicts. So they test the things and they go, okay, it's misapplied, the business model is in conflict. Then there's also concerns about those companies becoming competitors, some of the companies, so beware. And the other part of that on the educational side, supply chains and ecosystems, the very nature of them are beginning to change due to AI and more specifically machine learning. And that will continue. Now, in the AI side of it, it's not just machine learning. There are some, they're very narrow, they're small, they're algorithmic, but there's other issues too, and that's one of the reasons I use the term. When you're creating new knowledge, and that's when, or the potential to create new knowledge that the humans were not aware of, that's when I use AI. And you can do that, and the sum of the parts is much greater than the whole. At least the potential is there to do that, and many times more. So think about supply chains and ecosystems and business models an awful lot before engaging in this and how you do it. Financing is another big issue for, some architects spend a lot of time on it, some don't, but this sort of requires thinking about it. Right now, some estimates that I saw, the best one that I think is recent and most appropriate is 50% testing some sort of AI system, machine learning internally. That sounds accurate to me about what I see. Now, it's experimental, it's early. A lot of people are learning a lot of things, but we're also seeing already a lot of misapplication. The most common one is that data science and analytics, for obvious reasons, and there's been a steep learning curve, They're learning the new technologies, but some of the old issues are still there. To get budget approval within a department, sometimes it's easier to do just one little, machine learning project. It's safe, it can return an ROI, but it's physically impossible to overcome the most serious issues dealing with that the organization has to deal with in that manner. One quick example, there's a CEO I know that I won't mention, and their CIO a couple of years ago, and it came out in public, was, look, you guys are really, really good at big data analytics and doing these little projects in departmental, and they're showing, in some cases, the low-hanging fruit was creating good ROI, and it was good short-term projects internally, and it would cost a couple $1 million a piece, and they might make $4 or $5 or even $10 million off of it. That's all well and good, but the same company missed a huge trend that threatens their future. So that's the difference between holistic systems and unified systems versus sort of IT mentality sometimes and looking at it in departmental budgets. So how you do this in financing, that's also one of the reasons why we found it necessary to engage the senior-most teams. Because they're ultimately the CEO and the board governance are the ones responsible for this. And in that particular case, actually, to the credit of that CEO, told the CIO, who was a very good one, by the way, otherwise, said, look, I want you to do, we need billion-dollar improvement. We need, and not just to keep Wall Street happy, things are changing very rapidly. To stay competitive, we need bigger projects. We need to understand that. So this is quite a challenge because at the as budgets are tight, in many cases falling, companies and organizations of many types are being forced to invest and take higher risk. So that's something to keep in mind. Now it also transitions, as we said, in cloud computing, but different financing models. There's different ways to do this. There might be, not in every case, not in every industry, but in many cases there are. So career advancement, I noticed in reading the material of the association, which is perfectly understandable, and I've known quite a few architects, EAs. There's something for every kind of architect in our system, by the way. But I've been really close to it for a long time, and dealt with some really strong architects. I know it's a challenge faced many of the same issues that we face. What I would say is that with AI systems, in the near term, I don't see much of a threat. As long as folks are doing what we're doing today and improving the educational curve and learning curve, I see great potential. Actually, what I'm seeing is we're seeing more senior architects on the teams engaged with the senior management in our discussions that we did before. And like in our system, for example, it's universal issues, but in no way represents the entire enterprise architecture. We're talking about a critical core in the human interface, but there's an awful lot. There's literally hundreds of add-ons and integrations in a large, global company. So, but I would say that we need better alignment in the ecosystems, modeling. The relationships probably need to change, like they're changing in other industries. There's radical changes going on. The auto companies are changing just radically. In IT, look at the revenue on the IT giants are changing radically. So I would encourage creative and innovative thinking there, because we're working on some new models, and with others, we're not the only ones, but the companies we're dealing with. And then, finally, I'd say the ecosystems, they may need to be new or completely reconfigured. So that's something that it is occurring to some degree, and I would encourage you to explore those issues a little bit more. So in closing here, distributed AI systems are now finally viable. Costs have fallen dramatically, especially the hardware. They're starting to fall in the sort of the most basics, replicable machine learning and some automation, but it's still a significant investment, especially anything that's going to return an ROI. That's the flip side of this, is that it does require some investment. But to give you an idea, yeah, boy, 6-7 years ago, we estimated, in our case, before we had all these components, integrating and embracing, semantic structured data, et cetera, and machine learning was viable. We were actually looking at over $100 million for a handful of companies to build the first system from scratch. That's actually come down to the point where it's in single-digit millions of dollars for the initial pilot for the same organizations, with more advanced capabilities. In part because several years ago you needed one of the bigger supercomputers to do this, and it wasn't distributed, so that's how radically it's changed. But it still requires significant investment. A super majority of costs are in human talent. I don't see that changing. The ratios might change a little bit. I don't see that, the same with analytics. I don't see that changing a lot. Most valuable use case required a unified system. That is the case that we just drive home now. The research just shows it plainly as can be. The critical, fatal issues that are addressing companies and organizations and nations, it requires a unified system. You can't physically prevent these issues. You can't mitigate them. You can't even predict them unless you have a unified system. You've got to collect the data. It's got to be the right type of structure, hold the right information. Otherwise, it's guesswork. One-off ML projects are easier to fund, but you can't resolve or prevent the big ones. 3, governance is complex and critical. That hopefully we don't need to go deeply into that, but that's one reason why you need the board. And in our case, we've actually had quite a few research discussions with regulators around the world. It's unavoidable, especially in systemic issues. AI is number 4. AI is rapidly reshaping the largest industries. We expect that to continue. Ignoring it won't make it go away. IT models not necessarily best suited for AI systems. We need new options, financial models, alliance structures, and licenses. So with that, I think I better wrap this up. And there's my contact, and go to questions.
Okay, so an early slide mentioned physics. Can you say more about that, Mark?
Yeah, there's actually, we actually have some private publications that delve into that in more detail. There's a bunch of different really areas where physics comes into play. And I think it's one of the reasons why you're seeing, not just computer scientists, but you're also seeing physicists that are entering this area. But a couple of areas, one is they deal with advanced algorithmics. But compression is one, where a lot of this has to do about scaling and volume, at massive scale, at Google scale and beyond. So that's an area where you're dealing with latency, and it's almost entirely physics, really. But we apply the term in other ways. But that's one really good example where compression techniques over distance and dealing with time is almost entirely physics. And when you're dealing with distributed AI systems, like in the military, advanced systems, and that becomes really critical in real time. So that's one example.
Excellent.
I can give you another quick example though, that might be more sort of general. When you're talking about preventing specific events, one that I've used publicly, that's public out there, in 9/11 in the Phoenix memo, there was a memo that an expert within the FBI put out that found these questionable characters that were learning how to fly airlines, and their profile, which we rely on, didn't match any other profiles and for pilots, and so they were very he was very concerned about this, and it was one of the scenarios that actually they had run apparently, is that somebody using an airline as a weapon. And of course, nobody expected to be used so effectively that would create, end up in being multiple wars. But that's an example where you actually had a memo within an organization that if the right people had seen that and had access to it and been compelled to act on it, 9/11 may not have been prevented entirely. There's a lot of speculation on that, but it's almost certain. I mean, almost everybody agrees that it would have been mitigated. So, at least part of that event, some of those airlines, if not the whole thing. So that's kind of an extreme example, but the Japanese earthquake and nuclear meltdown were also, and if you don't have that data structured in such a way and your systems architected in such a way, and what I call a unified system, it's physically impossible for the individuals to know about it and to act on it. It's another example.
Awesome. All right, let's move on to our next question. Was this session an overview of your org's focus?
By org's organization?
I'm guessing.
Yeah, well, for the most part, if you look at the, if you look at the focus areas, I mean, let's say 75% of it was, I was trying to provide an AI systems a general kind of overview in the beginning of different types of systems, and then, drill that down into what our focus area is on organizational systems, which is in many ways more complex. Then that would be accurate. And then the module example that I showed is a manifestation of actually the theorem that is the foundation of our system and our work, and that just shows a manifestation of it being applied in the real world. So I guess the quick answer is yes.
Excellent, excellent. All right, moving on to the next question. Which areas are leading on the government systems apart from security and intelligence?
Well, by the looks of things, I'm not so sure about that even. The hacking tools in the news. It's a good question. Earlier in our time, we were more engaged with the government. It's been frustrating for us because of the limitations on contracting, et cetera, et cetera. While we've always considered our work to be very well applied to the government and a lot of interest in it, it's just very, very difficult for a small independent lab like ours to work with federal government. So we have really good relationships, et cetera, but we haven't done anything yet with them. I don't have a lot to offer there. I guess I could mention some areas that we've looked at. In terms of economics, the biggest concern in the United States is our healthcare system. It's almost 20% of GDP. I personally don't think that's sustainable. Many others would say the same thing. The costs are going up. If we don't harness this kind of technology, I produced our first, a platform for healthcare and shared it publicly in 2010, and it's still not adopted in the U.S. So if we don't adopt these kinds of systems, there's real question whether or not our national economy is even sustainable. The next costliest healthcare system in the world, I think, is about roughly half that of the United States, and I think we're ranked overall something like 16th or 17th in the world now. So for the U.S. government, that would be my recommendation, and it is privately and publicly, that we get our arms around it, and we better adopt these kinds of systems as soon as we can. But I can tell you that the conflicts are such internally that you can't rely on the entrenched incumbents to do it. Certainly not without competition, because they've had the chance for years now and they've refused. So that would be one area. But essentially, you can apply it in any organization, any kind of government. You can apply AI systems to, productivity is an area that is another core economic challenge that we're all faced with globally. It's been flat for years. It's a very serious problem. So we need all of our, especially with the amount of public debt out there, that is a very high priority. So those are a couple of really key areas that are universal, because if you fix, if you go a long way in fixing healthcare, that helps all governments, because they're around the world, overwhelmingly the payer. So.
All right, fantastic. Well, let's move on to our next question. What would be your advice for a new entrant into AL or ML?
Yeah. Well, be aware of the stampede, number one. Number two, I mean, the vast investment, I haven't gone through multiple cycles now. I'm real leery when there's too much dumb money in the market. It hasn't been too bad, actually, in AI so far compared to the dot-com era. It kind of requires a little more intelligence, but there's probably too many being funded. There's probably too much dumb money in it. I'd be very careful about that. And then an awful lot of the little ones that, there's a lot of little open source projects, and then you've got, major systems being done that are, when Google or Microsoft decide to open source something, that can wipe out dozens of startups. So I'd be very, very careful about entering at this point. One other point that's worth stating there is that most of the leaders in the world in AI systems, not technically, but in terms of strategic issues like this question, they've been around for a couple of decades. So the AI lab leaders around the world, you're only talking about a couple dozen that survived the AI winners. Those are the leaders in the world, and there's only a few dozen of them, and they, I can tell you in dealing with them, they have the best intel. So try and work with a leader if you can.
Awesome. Great answer. Great answer. Okay. Let me just get this one so I can see it all. We got a longer question for you. So, okay, it looks like this is more of a comment, but it says, thank you, Mark, for providing the amazing perspective. You do remind me of a physics professor and Richard Feynman. Would like to follow you to gain more understanding and contribute to yield positive results. So that's great.
Well, that is quite a compliment. Thank you, whoever that was.
Okay, and looks like we have just a few minutes while we get our next presenter ready to go. So if you have any last-minute questions, feel free to type them in the questions section, and we will try to get to one or two more questions before we have to let Mark go. And it looks like our next presenter is getting ready, so we should be ready shortly. So any last-second questions? Let's see if anything pops up. Okay, we'll go to this last question, and then we'll move on to our next presentation. What characterizes an organization that would be easy or difficult to start work with?
Well, it depends on what context and what level you're talking about. In our work, if you're talking about enterprise-wide AI system, I can answer that pretty quickly. Several years ago, only the largest global companies had the internal capabilities and the budget to be able to do this. Now we're actually at the point where I'm looking at the ability to provide this with small business soon. My goal was this year. I don't know if we're going to make it. But that's how radically things have changed. But if you're talking about just machine learning as an individual expert in machine learning, it's an explosion out there. There's a talent war going on, so it's a great time to have those skills. If you want to follow up in an email with me on giving more specifics, I'll be happy to take a run at that with more detail. So